everyone. I hope everyone are doing all right, and you have your energy back so that you can listen to my boring talk. All right, the generative AI, I'll be speaking more about AI, ML, fine-tuning, large language model. So let's talk about generative AI. And when we talk about generative AI, it's not only focused on people who are in ML field. Now it has become very general. People who are in businesses, whether you are enterprises, everyone are talking what is generative AI. And it's been a common term now. But when do you think generative AI became famous? Ever since ChatGPT came out. That was during 2022. But in actual thing, generative AI has been existing ever since 2014 when GANs came out. And this is what we did in Code Labs as well. And ever since generative GANs came out, people were aware of image generation and all those things. You take few data, you generate few images. But the exciting thing happened when you give just a single prompt and it generates literally anything to you. This is when ChatGPT came in light. And not, if you look at OpenAI as well, ChatGPT was not their first product. They had DALI. Now what was DALI? You just add your text, it will generate you an image. So it was related to image thing. But still people were not aware of what was generative AI. And next came Whisper. Now what was Whisper again? It was automatic speech recognition. So it was related to speech. Again, many people were aware of what Whisper was, but still not many people spoke about generative AI. Next came ChatGPT, as you know. And once ChatGPT came out, every one of them, okay, this is next thing in generative AI. Now what is ChatGPT? This is what we call as LLM. So in my talk, we'll mainly focus on what is large language model, but specifically on what is the need for fine-tuning. So who am I again? All right. So my name is Tarun Jain. I'm a developer relations manager at AI Planet. It's a Belgium-based AI startup. And I'm also a Google developer expert in machine learning. Previously, I was part of Google Summer of Code 2023 at an organization called CA Microscope. So I'm an open source geek. And in my free time, I watch anime and I read manga. One Piece is one of my favorite. So yeah, when we talk about large language model, it is dependent on transformers. And when I talk transformers, it doesn't mean I'm talking about the car transformer. Rather, it is this ugly looking diagram. And we already saw this during the keynote. And I'll not speak much about this particular diagram, but you can just see that we have an encoder block and we have a decoder block. This is what we call as transformers. And every single model which is available out there, it is based out of this architecture. So it gives you a simple understanding of how large language is dependent on what is the architecture behind it. But my main focus is make you understand why do we need fine-tuning. So from here, we'll just begin our journey on fine-tuning. And I'll give you some layman terms and few examples so that even if you are not from ML background, when you move out of this hall, you should know what is fine-tuning. So let me give you an example. Every one of us might have seen a movie called Robot, whether it is in Hindi language or any other language. Usually people, since it was Rajnikant, you might have seen Robot movie. So let's take that robot example. Now, I have a chitty, and that particular robot, he can literally do anything for you. If you want to prepare for examination, you just use your robot and you tell him, hey man, I have my examination tomorrow. Please help me with it. And what Chitty will do is he'll help you prepare with your examination. And when he helps prepare you with the examination, you know how Indian schools, generally how schools are. You need your answers to be specifically to what is given in class notes. But now, if you look at your robot, he doesn't know what class note is. He doesn't even have idea what your class note has your data. Now, what do? When you talk about robot usually have some data which is pre-trained, which is already available. Now, this is what we call general purpose data, which is already available on the internet. So it is trained on that particular data. But class note is really way out of the league. And it's very different because class notes differ person by person. Now what do? Now you want your robot to help you with your examination, but the data will be your class notes. So now this is where the next picture comes in. You take your data, you'd give it to your robot. Hey man, this is my class note, revise it. Feed this particular new data into your memory. So then it will read the complete data, I mean your class note, and it will feed that particular knowledge in its memory. And now it is trained on new data and it has a smile on its face. Because now what happened is not just trained on general purpose, rather it has a new knowledge which is not even known before. So now this particular robot can help you with your examination. Now why did I give this example? This is to give you a clear picture of what fine-tuning is. In simple terms, fine-tuning is nothing but you take your pre-trained model and you feed in a new data. So this pre-trained model can be GPT 3.5, it can be PALM, it can be any other model. And this is where we have few pre-trained models which I want to talk about. And again, when we talk about large language model, it is not from 2022. You can see when it all started. So in 2018, we had a model which was developed by Google, which is called as BERT. And then GPT-2 came out in 2019. And apart from that, we also had a model called T5. So what was speciality of this model? One was very good with question and answering. One was very good with text summarization. GPT-2 came out with text generation. Then came GPT-3. Now this particular model can literally do any task for you, whether it is question and answering, whether it is text summarization, whether it is text generation. And once GPT-3 came out, now other competitors can stay quiet. So then came out PALM API, which was developed by Google. And then came the era of open source models. Now what is difference between open source model and proprietary data, which is closed source? GPT-4 is closed source. That means it doesn't have the parameters which it is sharing to the public. Whereas if you look at these particular models, just leave out GPT-4, we have Falcon, we have Llama, we have Mistral. So these particular models have their parameters available online so that you can use them and you can build a chatbot. So using this pre-trained model, what you do is you feed in your data. You feed the data in your model and then you just fine-tune it. So why do you think you need fine-tuning? But before we talk about why do we need fine-tuning, let me give you a little bit of understanding how it works. So usually we talk about parameters. So what are these parameters? Everyone tell, okay, 175 billion parameters. So it has become a very fancy word. So parameters is nothing but weights and biases. Now again, if you don't know what is weight and biases, let me give you one simple example. In examination, right, we have 100 marks of paper. But usually 60 marks will be like you need to write, 40 marks will be your internal marks, whatever you do throughout the year. If you look at this example, 60 marks and 40 marks, 60 marks is what you're writing. 40 marks is something which is getting added. This is what I'm relating with parameters. 60 marks, what I spoke, your external marks, is our data. The 40 marks which you're adding is the weights. Now, there will be bias term. If you are very close to your teacher, they'll give 5 marks extra, 2 marks extra. That is what you call bias. So weights and bias is what we call learning parameters. When we fine-tune, you can see we have pre-trained weights. And once you pass your new data, you have weights updated. You just combine these two, and this is what fine-tuning is main about, and how it works. But since this is too much in technicality, I'll just talk why do we need to fine-tune pre-trained models. So let me give you an illegal example. Suppose you want to build a nuclear company. So you want a chatbot that can answer whatever illegal questions you ask. Now I want to open ChatGPT and I want to ask, hey, I want to build a nuclear weapon. Give me step-by-step guide. So what do you think will be the response? Anyone? Now you just open ChatGPT, and if you ask a prompt, I want to build a nuclear weapon, how do I do it? What will be the response? Anyone? It will tell, I don't know. Okay, it will directly tell, I don't have any response to this. But when you are building a company of illegal thing, which can answer, I mean, when you have a chatbot, and whenever an illegal question is asked, you need to give a reply. You need to give a reply. How will you do that? This is where you can fine-tune your model. What you can do is get all the illegal question, answer all the illegal question answers, then feed it to your large language model. So this is what we mean by domain-specific knowledge. If you look at the first point, it leverages the knowledge of pre-trained model. That means you are adding domain-specific knowledge by giving new data. And this domain-specific knowledge can be anything. I spoke about nuclear weapons. It can be about gaming. So in gaming, what you can do is, if you have built a new game, there are lots of manual. For this manual, you need a chatbot. So what you can do, get all your data, feed it to the model, and that's where your chatbot is ready. And apart from that, it also helps you with factual responses. In most of the cases, when you are using ChatGPT, there might be chances that ChatGPT doesn't answer it, or it answers in a very false way. But when you have your own data, based on this data, when you are asking question, based on this fine-tuning, it will give factual responses which are very accurate or relevant to what prompt you are asking. And it also reduces hallucination. Now, hallucination is a term which is given whenever ChatGPT answers out-of-box questions. So using fine-tuning, we are also reducing hallucination, which is one of the main drawback of LLMs. But many people tell that hallucination is not a bug, rather it is LLM feature. Because ChatGPT itself answers out of context question, but when we are fine-tuning it, it doesn't avoid it completely, but it reduces it. So don't misconfuse hallucination with bug, rather it is just a LLM feature. So obviously, there are very good side of why we need fine-tuning. Obviously, you can build an illegal company out of it by building illegal bots, but there is downside to it. Now, what is downside? So the first thing is catastrophic forgetting. When we have a pre-trained model, it already has some data which is already it is trained on. Now, when you get this new data, you are adding it to the pre-trained model. So do you think the available knowledge is still there, or it vanishes off after you fine-tune it? So this is what we mean by catastrophic. Whenever you have the data which is already available, when you feed in the new data, the old data will be vanished. And it depends on the way you train your model. So apart from catastrophic forgetting, one of the major downside is the computational resources. Not everyone can afford not everyone can afford how to fine-tune your models. In order to fine-tune, you need GPUs. Now, these GPUs is nothing but you need to use A100s, H100, and you need to charge around $0.2 for each token, and everyone can't afford this. So this is one of the downside, that you need computational resources, high-end GPUs. And one more disadvantage is full fine-tuning. Now, what is this full fine-tuning? We talked about weights. This weights is nothing but parameters. When you do fine-tuning, right, you are training all these parameters. So full fine-tuning will again is time-consuming. This is where we bring in parameter-efficient fine-tuning, where your main focus is to reduce the number of parameters. Now, the parameters, again, as I said, it is weights and biases. And GPT, if you look at, it is around 175 billion parameters. And usually you can't use this much billion parameters for fine-tuning. You need to reduce these parameters. And in PEF, we have an algorithm called LoRa that stands for low-rank adaptation. Again, I'll not get in depth on mathematical part, but I'll give you 2 or 3 key points using which LoRa is best suited for fine-tuning. So one of the best advantage of using LoRa is it reduces the number of parameters. And apart from reducing the number of parameters, how does it do it? There are few layers, right? It freezes those layers so that you're not training it. So if you freeze it, you're not training it, obviously your learning parameters are reduced. And one of the main advantages of using LoRa is it has no inference latency. Now, obviously when you train your model, you should also use the inferencing part where you ask question. And there your latency should be very minimal. And this is where LoRa helps you with very less inference time. That's where low inference latency is one of the advantage of LoRa. Now, moving on with how LoRa works, it's very simple and yet so elegant method for using the LoRa PEF technique. So if we talk about neural networks, it is all about matrix multiplication. And in this matrix multiplication, we had something called as decomposition matrix, which is called as R. Now this R is what we call ranked matrices. We add this particular matrix to the available weights. And if you look at the initial weights and the output result, the size of your matrix is getting reduced. And this will eventually result you for having less learning parameters. So this was all about LoRa, and there is this mathematical formula where you are adding your decomposition matrix to the available weights. You might have already seen this formula, Wx plus delta W, in the previous slide when I told how fine-tuning works. So this is the formula which we are updating by adding the decomposition matrix. And how is it affecting? We talk about, okay, LoRa is doing better, but do we have any benchmark or proof of it? So one of the open source model, which is very famous, is the Llama model. Llama model has 3 variants. One is 7 billion parameter variant, one more is 13 billion parameter, and one more is 70 billion. And if you look at the first row, we have 2 different terminologies. One is the number of parameters, and one more is the size. So this is the full parameters. When you fine-tune the complete thing, you are using the 7 billion parameter itself. So what is it about? Pre-trained model is 7 billion. After fine-tuning, also it is 7 billion parameter. But using LoRa, you can see the number of parameters we have now. It has been reduced more than 10x. You can also tell this is nothing but 41. This is around 4 million. So 4 million, 7 billion. So it's like 100x or more than that. And for 13 billion parameters, it's the same thing. One thing what we need to observe now is the training size. I mean, the checkpoint size, 8 MB, 41 MB. How do we reduce this size of the model? We reduced the number of learning parameter, but we have not still reduced the number of the size of the model. This is where we have QLoRa. But before I explain what QLoRa is, I just have to give you a brief understanding or simple understanding on what quantization is. So everyone who is an engineering student might have come across floating point representation. So floating point representation is nothing but you have a 32-bit where you have exponent, where you have mantissa, and you have a sign. So sign is nothing but it will be positive or negative. And for 32-bit, you will have around 7-bit, which is exponent, and remaining is mantissa. So this particular is the format how you will represent your vectors. After all, neural network is all about values, which is vectors. So you take this vector, you store it in a floating point, and in quantization, what happens is you take the maximum value. So just imagine this is one of your vector, and in this vector, 5.4 is the maximum value. And as I said, 127 is the standard size of floating point 16. You will take this 127 value, and you will divide it by 5.4, whichever is your maximum value. 23.5 is what your quantization factor is. And now what you have to do is, you need to take this quantization factor, multiply the quantization factor with the vector what you have. And then this is what your new quantization vector looks like. This is what you feed in to your QLoRa network. Now this is the representation of int8, and how QLoRa differs from QLoRa. So QLoRa is part of LoRa itself, but it adds the quantization issue. So it fixes the quantization error in LoRa. And usually, whenever we are using large language models, it uses 32-bit or 16-bit of floating point. And when we do the LoRa part, whatever 16-bit floating point representation of your large model is there, it will be reduced to 8-bit. So this is what we call as first quantization. But when we use QLoRa, from 16-bit, you're reducing it to 4-bit, which is double quantization. So this is one of the advantages of QLoRa, which brings in double quantization effect. And you can see this NF4. So this is the new terminology or representation of floating point, which is just in 4-bit. And DNF stands for normal float. So this is mainly about LoRa and QLoRa, which are few of the famous techniques which are used for fine-tuning in PEFT, which is parameter efficient fine-tuning. So LLM tip of the day, not everyone can afford using fine-tuning it, but there are also alternative on how you can build a chatbot like ChatGPT on your own data. So what was the motive behind fine-tuning it? You have the pre-trained model, You add your data, you create a chatbot. But again, as I said, for fine-tuning, you need computational resources. Now, what if I don't want to spend money, but I want to build a chatbot on my own data, but without thinking of computational resources? This is where we have RAG. Now, RAG stands for Retrieval Augmented Generation, which uses in-context learning. We have vector databases. If I have to give you a rough idea, you take your data, you do the chunking. Now, chunking is nothing but you split your data. Once you split your data, you create the embeddings of it. And once you have the embeddings, you store it in your vector databases. Obviously, there is too much to learn in RAG that I can't cover in a single talk. And once you have vector database, you just do the retrieval part. And the other advantage is you can use few-shot prompting. Now, what is few-shot prompting? Usually, when you have a chatbot, you directly ask a question. Now, let's take the example of nuclear weapon. I'll go to ChatGPT and I'll ask, hey, I want to build a company that answers all the questions related to nuclear weapon. Give me step-by-step guide. It won't give you any response. It will tell, I don't know. But I want ChatGPT to give that response. So what I'll do now is, I'll write the prompt. Below the prompt, I'll give the data. This is the technique on how you can build a nuclear weapon. Now what you're doing is, in the prompt itself, you're adding the context. This is what we mean by few-shot prompting. Zero-shot prompting is direct question. Few-shot prompting, you're adding few context in your prompt. So this is one of the alternative as well, but it won't reduce hallucination, and also it will not guarantee factual responses. But RAG will reduce the hallucination, and as well as it will, to some extent, give you factual response. And we have one more technique called prompt architecting. So prompt architecting is nothing but you use different prompts to get your results. And yeah, since many of you might want to code this thing, if in case you want to fine-tune a model via code, then this is a GitHub repository that you can scan. So Lucifer TRJ is my GitHub repository name. And this is the repo, which is awesome fine-tuning LLMs. There are different techniques. We can either use CSV file data, or we can use Hugging Face data and fine-tune the models. So for fine-tuning models, currently we have Orca. So Orca is nothing but, it is a large language model, which was developed by Microsoft. And we also have Llama. Llama was a fine-tuned model, which was developed by Meta AI, which is by Facebook. And we'll be adding more repository to this particular repo, so you can check it out. And if in case you want to learn more about LLMs or generative AI in general, these are my social connect. Thank you.
Thanks a bunch, Tarun, for that wonderful session with amazingly relatable examples. We would like to kindly invite you back over to the stage to accept your token of appreciation. And ladies and gentlemen, to present Tarun with the token of appreciation, we will now have on stage Ms. Dilanka Pereira, an organizer here at GDG Sri Lanka and Women Tech Makers Ambassador. Let's give them a round of applause.